If you thought the deepest views of the cosmos were already breathtaking, the latest images from the Euclid Space Telescope will shatter everything you believed about the universe. This extraordinary observatory has just unveiled new observations so sharp, so expansive, and so profoundly revealing that researchers are admitting they were utterly unprepared for the implications. Euclid has captured vast deep fields teeming with millions of galaxies, exposing hidden gravitational lenses, intricate cosmic structures, and hints of invisible forces on a scale never seen before. These aren't just pretty pictures. They uncover patterns driven by mysterious energies, distortions shaped by unseen mass, and a universe far more interconnected and enigmatic than our theories anticipated. Tonight, I'll guide you through what Euclid has revealed, why experts are hailing these as game-changing, and why the discoveries emerging feel deeply unsettling the more you comprehend them. Stay until the end, because this is merely the prelude to Euclid's full cosmic revelation. Euclid is no ordinary space telescope. It was never intended to linger on one stunning nebula or pinpoint a single distant galaxy. Its ambition is vastly greater and profoundly more challenging. Launched by the European Space Agency in July 2023 and stationed 1.5 million kilometers away at Lagrange Point 2, Euclid was engineered to survey the universe on an unprecedented scale. Its exceptionally wide field of view captures huge swaths of sky in one exposure, while preserving exquisite detail. This allows Euclid to resolve individual galaxies clearly, even as it maps how billions interconnect across immense cosmic architecture. What truly unsettles is that Euclid doesn't merely image visible light. It probes the invisible through faint gravitational distortions in galaxy shapes, known as weak lensing. In essence, Euclid is illuminating the hidden scaffolding of the cosmos, a framework dominated by forces we cannot directly observe or fully explain. When Euclid released its latest deep field previews, covering enormous regions of sky in unprecedented clarity, the astronomical community was overwhelmed by the volume and precision of the data. In just initial observations, the telescope imaged over 26 million galaxies across its 3 deep fields, with some views revealing more than 11 million in a single frame. These previews represent only a tiny fraction of Euclid's planned survey, yet they already showcase galaxies stretching back over 10 billion light-years. The realization hits hard. This is not a complete portrait, but a mere glimpse of 99% of the final map remains unobserved. Scientists can seamlessly zoom from sprawling large-scale structures to the intricate details of distant galaxies, exposing how matter is distributed across cosmic history. These images are more than visuals. They foreshadow the most comprehensive 3D atlas of the universe ever constructed, one that immediately challenges how much of reality we've truly grasped. One of the most profound shocks from Euclid's new data emerges from its deep field south, where a single observation uncovered hints of the cosmic web. Vast filaments of gas and matter linking galaxy clusters across hundreds of millions of light-years. This field alone harbors over 11 million galaxies, bordered by enormous voids and dense nodes. But the true revelation came upon closer analysis. Euclid detected hundreds of strong gravitational lenses, rare alignments where foreground mass warps the light of background galaxies into arcs and rings. These lenses, far more numerous than anticipated in early data, act as natural magnifiers, revealing distant objects otherwise too faint to see. Their abundance suggests dark matter concentrations are more complex and pervasive than models predicted. The universe isn't just filled with dark matter. It seems orchestrated by it on scales that defy easy comprehension. Euclid's observations are transforming not only vast structures, but also intimate details within familiar cosmic environments. In regions like dark clouds pierced by its infrared gaze, Euclid uncovered shimmering veils of gas and dust where new stars form, alongside faint populations of free-floating objects. In galaxy clusters, it resolved thousands of previously hidden members, including dwarf galaxies sensitive to gravitational tides. And in previews of merging systems, Euclid captured sparkling interactions where tidal forces reshape spirals into intricate patterns. These findings depict a universe that's not static or serene, but vibrant, turbulent, and perpetually molded by both luminous processes and shadowy influences that pull from afar. As researchers processed Euclid's expanding dataset, an inescapable pattern surfaced. Galaxies do not drift in isolation. They align along immense cosmic filaments, colossal threads spanning billions of light years, converging at massive clusters while surrounding expansive voids. Euclid's wide field precision renders this web strikingly visible, resembling a vast interconnected lattice more than a random scatter. Matter appears to flow along these pathways, distorted and guided predominantly by dark matter's gravity. The disturbing aspect isn't the web's presence, but its dominance. The visible cosmos seems merely tracing lines drawn by something intangible, controlling distribution and evolution on the grandest scales. Euclid excels at detecting weak gravitational lensing, those minute shape distortions in distant galaxies caused by intervening mass. Across millions of objects, these subtle shears accumulate into a map of hidden matter. Euclid's new images reveal hundreds of strong lenses alongside countless weak signals, painting invisible hollows around clusters and filaments. These unseen structures bend spacetime profoundly, yet emit no light, outweighing the visible universe many times over. What unnerves is their silence. They shape everything we see without revealing themselves, forcing us to infer a dominant reality from faint echoes in the light of others. Euclid's gaze extends deep into cosmic time, capturing galaxies as they appeared when the universe was young, alongside nearer ones in the same vast frames. This allows direct comparison of structure across billions of years, tracking how the cosmic web assembled. Early results suggest clustering occurred more rapidly than expected, with dark matter collapsing into halos sooner and pulling baryonic matter along faster. The universe appears to have matured with surprising efficiency, challenging timelines of gravitational growth and hinting that our grasp of fundamental forces may be incomplete. The most sobering truth is this: everything described stems from just a fraction of Euclid's survey, with deep fields observed only once so far. Over its 6-year mission, Euclid will revisit these areas dozens of times, deepening views and refining maps while surveying 1/3 of the sky. If preliminary data already exposes such intricate lensing and web hints, the complete dataset could overwhelm current cosmology, reshaping understandings of dark matter clumping, dark energy's push, and the universe's accelerating fate. Euclid's data highlights not just dense regions but the vast emptiness between, cosmic voids spanning hundreds of millions of light years, seemingly barren yet profoundly shaped. These voids are bounded by filaments, their edges defined by repulsive forces accelerating expansion. In Euclid's previews, voids appear as sculpted absences, where dark energy actively clears space, stretching the web thinner. The implication chills. The cosmos isn't merely expanding passively, it's being torn apart by an evolving pressure we barely comprehend. Designed to probe both dark matter and dark energy, Euclid measures galaxy positions and redshifts across billions to chart expansion history. Initial analyses of its deep fields show subtle tensions with standard models, where growth of structure deviates faintly from predictions. These hints suggest dark energy might vary over time, not remain constant. If substantiated, this would upend cosmic chronology, portraying the accelerating force as dynamic and unpredictable. With Euclid's data volume exploding, a new hurdle arises: The information defies human-scale intuition. Billions of galaxies in 3D demand advanced computation to discern patterns. Machines now interpret what machines observed, creating a loop where cosmic understanding relies on algorithms processing beyond direct grasp. The unease lies in how much of the universe may transcend intuitive human comprehension. Euclid's sharp revelations underscore a foundational unease in physics. Dark matter and energy dominate, yet our explanations rely on approximations and unknowns. Euclid maps their effects with precision, but the underlying nature eludes us. We see influences without sources, distortions without direct detection. It's exposing not just the universe, but the boundaries of current knowledge, a realm where most mass and energy operate invisibly. Euclid's images captivate at first. Galaxies in myriad forms, clusters gleaming against the void, lenses curving light into elegant arcs. Yet prolonged examination turns awe to disquiet. Every crisp detail, every aligned filament, every magnified ring testifies to relentless forces enforcing order across voids. Beauty here signals inexorable mechanics, gravity binding, dark energy repelling, all with unflinching precision. Euclid reinforces a profound hierarchy. The visible is subordinate. Dark matter halos coalesce first, dictating where galaxies ignite later. Lensing maps confirm this invisible precedence, with baryonic light merely illuminating preordained scaffolds. The visible universe decorates a hidden architecture, secondary to the unseen governing its form and fate. Euclid compresses eons into single vistas. Nearby mature galaxies beside primordial ones, ancient light coexisting with modern. This frames history in space, allowing evolution tracking of shapes, clusters, and dark influences. The startling insight, our present is a fleeting layer in an ongoing saga, predating and outlasting all we know. As Euclid advances its mission, anomalies already emerge, unexpected lens frequencies, subtle web deviations not fitting neatly. New instruments historically yield surprises. Euclid's breadth may demand revisions to gravity or new physics. The possibility looms that the revealed universe defies full explanation with existing frameworks. Euclid captures dual scales effortlessly, immense webs alongside fine galactic details in one exposure. This unity reveals discomforting linkage. Forces sculpting cosmic filaments also govern local star formation. The universe interconnects systemically. No clean separation between grand and intimate. Many targeted regions were well studied, yet Euclid uncovers novelties, new lenses, hidden dwarfs, faint arcs missed before. This exposes prior incompleteness. If familiar skies held secrets, unknown realms must abound in layers. Confidence in past views erodes. True perspective demands Euclid's unparalleled vision. Euclid's deep reach acts as a time portal, placing galaxies in precise space-time via combined imaging and spectroscopy. Reconstructing web growth from uniformity to complexity, data implies swift organization. Dark matter efficient, structure aggressive. Evolution appears bolder than gradual models allowed. Euclid's analyses accelerate questions over answers. Each lens probes gravity. Each deviation questions energy constancy. It's not bridging gaps but widening them, revealing knowledge as tentative. The universe may demand inquiries beyond our current imagination. Stepping back, Euclid's revelations terrify not through chaos but precision, a structured, interdependent cosmos ruled by invisibles. Dark matter architects, dark energy dismantles, gravity mediates, all beyond perception. Visible matter follows dictated paths. Structures arise where allowed. Even voids sculpt under ancient forces. This machinery formed our home, yet operates indifferently to our existence. We inhabit no stable island in quiet space. We traverse a dynamic edifice of enigmatic physics, expanding under rules only now glimpsed. Euclid's images enchant, yet truthfully depict a cosmos prioritizing the unseen, the immeasurable, the uncomfortable. This is Inception. Most data awaits. If early views challenge dark matter, energy, and evolution so profoundly, the entirety may compel radical rethinking. To remain at the forefront of these breakthroughs, to grasp implications beyond surface beauty, subscribe now. Share thoughts below. This era redefines boundaries. The universe Euclid unveils endured eternally. We're only now confronting its true essence. What hidden force will next reshape your view of reality?